Good morning, year 13. I've got to call you 13s now. How exciting is that? That's nice, right? It's nice to be year 13s. It's so nice that I've already got people here waiting. You guys are fab. Thanks for being here on time. Look at that. I've even got Ria. Hi, Ria. It's nice to see that your computer's working again. Right, let's get the register done. Okay, right. Hey, Mika. Hey, Ivan. See, I'm on the mean beans. So I've got Dat. I've got Ria. I've got Ivan. I've got Nikita. Got Mika. Got Dana. Got Kayun. Amazing. There we go. We're doing really well. What a great start. How are you guys? Is everyone okay? Is everyone coping with the new extended OMCO? Is that OMCO? Making up those letters. I think it is. Something like that. Are you guys all well and happy? So today, there's Emma. Love it. Doing really well. Only 4 people missing. How amazing is that? I'm missing Jasmine. And in fact, I've only got 3 people missing. Jasmine, Ben, and Tenzi. That's all I'm missing. I know that Ben tends to be a little bit late. I think Ben likes to sleep in. You guys are awfully quiet on the chat this morning. Can I just say I spoke to Nikita yesterday, and Nikita was busy doing some of the kinetics booklets from the AS support sheet, which was amazing. I am very aware that I completed the GCSE support sheet, and then I completed the AS support sheet. I have yet to start the 13 support sheet, so I will endeavor to try and get that done before the start of next year. I am very aware that there's a lot. It takes an awful lot of work and a lot of hours of me staring at a computer screen, and I'm doing so many already that I just kind of feel like I might not be able to get it done. But I will do the very best that I can to have it all sorted for you guys. So okay, I'm going to assume that. Going to assume that Jasmine, Ben, and Tenzi they're running late, so I'll. But I think I know that Sherlin's not going to be turning up now, which is fine. She shouldn't actually really be on the register, but I'll look into that. The others I will mark as not here, and then I can always update that later on when they arrive. Oh, there's Jasmine. Just Ben and Tenzi that I'm missing now. But I'll mark those 2 as missing for the time being. And then I will sort the rest. Okay, so guys, last lesson we started the process of kind of getting into grips with kinetics. And we did kind of a really brief summary of kinetics, and we looked at things like Maxwell-Boltzmann curves and all that stuff. And today we're going to start real A2 content. So we're going to be focusing primarily, we're going to be looking at orders of reactants. You can see the learning objectives on the YouTube chat. I'm just trying to find my notes that I gave to you, that I started with you guys. It's actually going to be tricky. I'm going to have 2 sets of notes. That's going to be a little bit tricky, that one. So I'll start another one for that. Should probably do 2 separate classes, really. I'll add a section. So I'll do A2 Unit 4, and I'll rename that one as, I can't remember what, you guys are 12A or 12D. I can't remember which one you guys are. Let's have a quick look. So you guys are 12E, and the other class is 12D. So this is 12D's notes. And then I'm going to start a new section being A2. I'll rename that. A2 Unit 4. And I'll put brackets 12A. Sorry, 12E. There we go. Okay, and then I'm also then going to see if I can cut and paste the no, I can't cut and paste the learning objectives. Not that it makes a difference. Okay, let's crack on, shall we, folks? I will share my screen with you guys. Share screen. And then click on that one. There we go. So there's my screen. Oh, there's Tenzi. Tenzi, I'll mark you on the register as you're in. Nice to see you, Tenzi. Thanks for coming. Okay. So this is where we're up to. So we are starting for the first. This is genuine. So this is A2. So these are your first real A2 notes. So these are the notes that you now want to be taking. We're doing A2 Unit 4. Now I might switch. I've got you guys 3 times a week. The other class I've only got twice a week, and I'm very aware of that. What that actually means is most likely I will actually continue teaching you guys Unit 4, and I'll switch to Unit 5 on the other class. Chances are is what's going to end up happening. Unit 4, and it's kinetics. Now we are focusing today our three learning objectives. I need you guys to understand. Of course, we know that we have three different learning objectives. Understand, knowledge, and able to, and most of mine understands today. So we need to understand concentration. And we will run Kickass on concentration again, because we will put it into an A2 setting. I then need you to understand the order, I'll underline that, order of reactants. You need to understand what that means and how that translates to experiments. And then the very last one is to be able to use data to determine or to find order. I'm going to actually keep the learning objectives exactly the same as the ones I've got on YouTube. I think that was what I wrote down. Okay, so in at AS chemistry, what we focused on in kinetics, we focused on, number one, an understanding of particle theory. And we were using particle theory to explain rate change. Yeah, be able to explain rate changes. So this is what we focused on. Then we, of course, we picked up rate graphs and Maxwell-Boltzmann's and all of that, but that was the main focus. And this was technically, can I just point out that both of these are still actually IGCSE. The difference is the fact that they're now going to ask you and they're going to make the questions a bit more challenging. Yeah, that's what they did. And we had all 5 things to explain. We had to explain concentration changes. We had to explain temperature changes. We had to explain the addition or removal of a catalyst. We had to explain surface area change. And we had to explain pressure changes. These were what we were focusing on at AS level and IGCSE. And now at A2, this becomes a whole lot more mathsy. And we are going to focus on one particular scenario, and that's concentration. So you can underline this and just put concentration. So this is now the primary focus. Now, I'd love to think that you guys are going to be able to guess, maybe not, maybe guessing is it's a bit of a reach, this. So, okay, so here's a question on the chat then. Why do you think concentration becomes the focus in A2 and the others all drop away? Does someone want to suggest maybe on the chat? And it is, by the way, this is a very open-ended question. I recognize that the answer is not the easiest kind of leap. It's a bit of a leap of faith, this, folks. But would anyone like to throw out on the chat maybe a reason why this becomes our focus? So concentration is A2 kinetics. And the question is why? So why does it become the focus? So the question, why concentration? Why concentration? Why not the others? I'll leave the answer blank just for a minute. Okay. Just wonder whether or not anyone's. It would be nice to see if anyone's done any reading ahead. Nobody's saying. I don't quite know how long the delay is today. The delay on the chat seems to be fairly variable. I'd like to think that you guys are all listening to this, and I also realize it's used more in industry. Ivan, what a great answer. Yeah, so let's do that. So I'm going to put used in industry. Used in industry. And Ivan, your answer is correct. It's good. Yeah, it is used in industry heavily, but that's not the real reason. But that's a really good, I love that, because it is about industry. It is. Anyone else like to offer me another answer? It's not the real reason. I'm going to see if I can walk you guys to the epiphany. Free energy. Wow. Free energy. Gibbs. Oh, delta G. Kayan, it's nothing to do with energy. Nothing to do with energy. Good idea. But it's not. Let's see if I can walk you to an epiphany. Okay, so question two. So Ivan, you're now famous on YouTube. Ivan decides to double the concentration of one reactant suggest, or no, doubles rate, question mark. So this is where Kickass comes into play, of course. Everyone here knows Kickass. And our answer, now the answer is Kickass, and I'm going to get you guys to run it for me now. But the problem is, of course, this is, by the way, I'm going to emphasize a word here. I'm going to emphasize the word double. Can somebody now explain to me what's going to happen to the rate? Run Kickass for me on the chat and give me... Is Donna here? Donna's usually so good on the chat. Donna is here. Donna was first in the room. Donna, can you tell me, can you run Kickass for me? What's going to happen to the rate? It should be Kickass, the pirate version. Yeah, because, so just to remind the students who've never had Kickass before, anyone's watching this in anywhere else. So K, of course, is knowledge. And that's particle theory knowledge most of the time. Collision frequency, yeah. Activation energy. That's actually particles with activation energy. Oh, Ben's here. Ben just writes D. Nice. Successful collisions. Cols. So that's the number of successful collisions. This is number of particles with activation energy, parts with activation energy, and this is rate. Yeah. Donna lost connection, so she's 10 minutes behind. Okay. So can someone else run that, please? Increase the number of particles per unit space. Okay, right, Ben. The reason why, Ben, you're wrong is because to say the increase, so Ben put increase in it. Unfortunately, he's lost it because he didn't focus on the word double. Yeah, if we've doubled the concentration, there's more in here, Ben. We've got to say double the particles per unit space. That has to be there. Yeah, double number of particles. This is very specific. Doesn't the rate depend on the order of reactants? I'm coming to that, Dat. Coming to it now. Double number, but Dat, I still need to make sure that you guys are able to manage the AS ones and how that translates to A2. Double the number of particles per unit space. Collision frequency will double. Yeah. Double collision frequency. Yeah, call freak. Double number of collisions. I'm just going to put this in easy speak. Activation energy doesn't count. Double the number of successful collisions. We have an expectation, double number of successful collisions, successful cols, and therefore everyone here should be able from AS to predicted / expected from AS rate should double. That's what we would expect from AS kinetics. However, the answer to the original question, why does A2 focus on concentration? The reason being, it doesn't always follow expected particle theory explanation, EXP. I'll actually put explanation. So it doesn't always follow. It's a rather interesting thing, this, because now what we're going to do is we're now going to look at this. We're going to do something that Einstein did throughout his entire career. And this is what I am left with now that we are teaching online. Yeah, I am having to do what's called a thought experiment. Now, this is an experiment. A thought experiment is one that you do in your head. So let's run our experiment. So what we're going to do is we're going to react A and B, and it's going to form AB. Let's keep it simple. Yeah, let's keep these let's do them all as aqueous. We don't mind that. All aqueous. It's not reversible. It's unidirectional. We've kept it super simple. Yeah. And what we're now going to do is we're going to do an experiment, EXP1. And what we're going to do is we are going to use concentration in our experiment. We're going to vary this. So we're going, nota bene, we are going to vary concentration. Now, if we want to investigate, this is why I don't know why I ran off the screen like that, when I can just move the screen over. Vary concentration. And what I now want you to think about is if I want to investigate A, yeah? Now, and there's another nota bene we need to make, a second nota bene 2. Concentration now gains a symbol. Now, I will have already introduced you guys to this. In fact, I know I did. And that symbol is a square bracket. Yeah, square brackets represents concentration, and the units, you need to know these, the units are moles per dm cubed. Yeah, that's what these square brackets now means. Yeah, you see square brackets in A2 and you go, it means concentration. We know this. Okay, so what we're going to do is we're going to vary the concentration of A. Now, if I want to investigate A, here's the question on the chat. What do I need to do? This is where, Dan, I know that you've read ahead, which is great, but I just want to just tone it back, just pull it back a bit, and just go through those simpler questions. So if I want to investigate A, yeah, this is what I'm going to investigate. What must I do to B? If I'm going to investigate the effect of concentration change on A, what must I do to B's concentration? Now, these questions do get asked in the exam. They phrase them slightly differently. The question in the exam would be, this is an exam question, a student wants to investigate the effect, it's effect, isn't it? The effect of changing conc of A, describe a simple method. And that would be 3 or 4 marks. Yeah. So, and that is an A-level question. Yeah. They're wanting to test that you understand that if you want to investigate somebody, that you also know what you must do to everyone else. Yeah. So what am I going to do to B, folks? No one's put on the chat yet. I know that there's probably going to be a delay and people are pausing it and going back and making notes. I totally understand all that. Yeah, I really do. Okay, so what we're going to have to do, if we're going to investigate A, we're going to do experiment 1, and I'm going to put concentrate. Let's do square brackets around them. Yeah, moles per dm cubed. I'm just kind of trying to make it easy for everyone to see what's going on here. Yeah, and I'm going to start off, keep B's concentration constant. Thank you, Ria, spot on. That's the important bit. Yeah, we're going to, the mark scheme would be, and it says a simple method. Yeah, we would say something akin to, we will double conc of A, keep conc of B constant, keep conc of B constant, monitor rate slash, and then the monitor rate, compare rates of EXP 1 and 2. So we've got to do a minimum of 2 experiments. Yeah, we are going to do an initial experiment 1. Let's keep it simple. Let's do a concentration of A as 1 mole per dm cubed. Then let's do the concentration of B at also 1 mole per dm cubed. Let's now, as a thought experiment, let's measure the rate. And the rate is 10. Now, this is where I need to give you units for rate. Now, the units of rate do every now and again vary, but in reality, the ones that are most commonly used at A level are moles per dm cubed per second. And you do need to know that unit. That's actually quite important. We pick up a unit of rate because they're not trying to trick you. They're not trying to make this overly complicated. Every now and again, it gives you moles per dm cubed per minute as a trap. But in general, they tend to stick with moles per dm cubed per second. That's what they tend to do. So we've run our first experiment. And by the way, I should actually say over here is it's not, of course, A and B. A and B doesn't really factor in. We don't really care. It's just rate. Shouldn't now have an experiment. I haven't have an experiment line. There you go. So, twice as many particles per unit space, twice as much collision figures, twice as much successful. Sorry, I'm late, 10 minutes behind. Yeah, no problem. Dana, rate doubles. Well done. You're doing great, Dana. Thank you. You're a star. No sad face needed. So, we're going to do a second experiment. Now, we know that we're investigating A, and so therefore we know we need to keep B constant. So we're going to keep it simple. This is where everything starts. You don't want to jump in and go crazy and start doing all kinds of mad experiments. What you need to make sure that we're doing is doing everything on a basic level, keeping it nice and chill. Yeah, so we're going to double. Yeah, we're going to double A. So 2 moles per dm cubed. And we're going to keep B the same. Okay, so we would, as a result of AS chemistry, sorry guys, I was just reading a quick email, I do apologize. As a result of AS chemistry, we could make a prediction, and they would expect us to be able to do this. Yeah, the prediction would be 20. We've doubled A. This is where the highlighter one's not the best choice, is it? That we here have doubled this. This has been kept constant. Yeah, I'm just going to put same. Yeah, and then we would expect from AS at times by 2. That's what we would expect. However, we're running a thought experiment. And surprise, surprise, it doesn't do. And this here is the real result. Real result. Okay. So guys, can someone tell me on the chat what effect has the change in concentration of A had on the result? I know it seems awfully stupid for me to ask that. It just seems like, why would he ask such a stupid question? Yeah. But actually, there is like a small amount of trying to make you guys just to think within this like common sense boundaries and to get you to kind of, because these questions again do get asked and sometimes students think they're too easy. Yeah. So the question now is, what effect has A had on rate? Question mark. It's really straightforward. Everybody should be able to post on the chat at this stage. Everybody should. Looking at our thought experiment, what effect has A had on the rate? Who's going to be first on the chat, just to let me know? I feel like there's a big lag on this. I feel like everyone's slowing down so they can try and no effect. Thank you very much, Ivan. Spot on. The answer is no effect. It's had no effect. Now, that was an absolute mind boggler. When that first happened, when industry started kicking in and they started wanting to make chemicals on an industrial scale, this is where Ivan's answer is so important. They, of course, thought, well, hang on a sec. If I increase concentration, I can make more. But then something strange happened, and that is they realized that not everybody had an impact. Not all of them did what the particle theory was suggesting. And they had to then explain this. They had to then create a language in kinetics to talk about this. So at this stage, what effect has A had on the rate? It had no effect, and they now created new terminology. They now said, as a result, yeah, because A had no impact, no effect on rate, they gave it a name. And the name was said to be that A, and by the way, notice that I'm literally writing this. I'm very aware that chemistry is a language. I have just written down A's concentration is what I've just written down there. I'll translate. This is the symbol version. Here's the words. A's concentration is zero order. And that O is a power. Yeah. A's concentration is zero order. And that literally translates to A's concentration has no effect on the rate. Let's write that down. This translates, yeah, to A's concentration, conc, has no effect on rate. Okay. Now, this is where I do things. Because I write all my notes and I give my lessons, you know, and I do all this freehand and I talk you guys through these things. It means that every lesson comes out slightly differently. So, okay, Ivan, I'm asking you specifically here because you are the one that's giving me those answers on the chat and I'm really liking them. So, Ivan, in industry, now this is where it's a very different set of questions. As a result of this, ... in industry, what would they do to the concentration, to the conc of A, question mark. In industry, you discover This is where all these little conversations are super handy. You discover you're making something, and the effect of one of your reagents doesn't make any difference. So what would you do to its concentration? Because it seems to have no impact in industry, what would you do? Ivan, it's on to you. This is a question, of course. Answer? This is a question. Don't like that, it's not a very neat question. What do you think they would do, Ivan? Or anybody on the chat? Interesting question. LOL. Go on, Ivan. What do you think they would, what would you do? It makes no difference. Keep its concentration to a minimum. Emma, you star. Totally beat Ivan there. Well done. Answer. Keep it. Can I just point out, Emma, you have actually no idea how good your answer is. That's a superb answer. Yeah? Keep the conc of A to a minimum. That is the right answer. Minimum. Keep it to a minimum. Yeah, we wouldn't, by the way, most students would write decrease. Yeah, decrease the concentration of A. Save money. That answer is wrong at A level. The reason being is because if you just decrease it, you could just decrease it endlessly. Yeah, you just take it down and down and down and down, save money. But eventually, of course, it stops being zero order. Just to make the note here, yeah, that A is zero order until you get to incredibly low concentrations. This is where I'm going to draw a graph for the first time. So we want to have the concentration. This is the concentration of A. Notice how my graph becomes easier for me to do now that I've got symbols. I don't have to write everything down. The concentration of A, this is 0 and this is high. That's funny. Don't really need numbers. So we realized that A is 0 order. So if I increase, we realize, and this, by the way, this is rate, which of course we now recognize as moles per dm cubed per second. I'm going to pick up that unit. And what we would expect to see is this, a straight line graph. Because what does this say? This line literally says, as I increase the concentration, increase conc, the rate doesn't change. It has no impact. Well, in reality, now, by the way, this is the graph you will draw. This is the concentration versus rate graph. But actually, now, by the way, this little detail is not really needed for A-level. This is first year degree, technically. But it is. But they have asked it, which is really frustrating. Then people often say, that doesn't mean you have to teach it. Well, it's not on your specification. I teach this because of the question that appeared. Yeah. In reality, if you were to zoom in on this graph, here's what the line really looks like. That's what it really looks like. Yeah. We realize that for most of it, yeah, all this section, we see 0 order. Yeah, 0 order. However, and it's 0 order because ... 0 order as conc increases, the rate doesn't change. No rate change. Yeah, this makes sense. But we do realize that you still need, yeah, Emma, I'm really impressed with your answer. It was fab. We still recognize that there is this little section here, yeah, which simply says that it clearly maxes out almost immediately. We still need A. You can't. One student, by the way, this has been a multiple choice, you see. And the multiple choice options to this question, yeah, were things like, it was decrease concentration, keep to a minimum, remove A entirely, yeah, and lots of students picked decrease as the major answer. Some even said remove it, you know, but in reality, you can't make A, B without A and B. So you still need it, but we're going to keep it to a minimum to save money. Yeah, well done, Emma. Such a great answer. Yeah. Okay. So it's nice, by the way. I didn't do this with the other class. That's the first time I didn't draw that with the other class, and I wish I had. It's just because of the way that the lesson turns out. So, okay, now that we've seen zero order, we need to continue our thought experiment. Yeah, let's go back to it. Let's go back to A. Yeah, concentration of A versus and the concentration of B and its effect on the rate. Yeah, we're going to do another thought experiment. We now know that A is zero order because EXP1 we did 1 molar and 1 molar and the rate was 10. We then did EXP2, experiment number 2, and we doubled A. We kept B constant and the rate didn't change. Yeah, so we said we times that by 2 and this did nothing, no change. A is 0. Well, now who do we need to investigate? We now need to investigate B. We're not finished. We know the order for A. A makes no difference. We're going to keep A to the minimum. But what about B? We need to do a third experiment, EXP3. By the way, just to tell you that this actually is all part and parcel of this question up here. Double conquer, keep B constant, monitor rate, compare rates of 1 and 2, determine order. The next bullet point would be now keep concentration of A constant, double B, and compare the rates of these two experiments. You need these bullet points continue when you have to investigate 2 reagents. So I'm now going to put onto the chat, guys, what do you want me to write here and here? Here's X and here's Y. What do you want me to put for X and what would you like me to put for Y? Now, when I put this out to the other class, Winkit went mad. They went completely mad. What numbers do people want to have for X and Y? Now, the important thing here, guys, is keep it simple. Yeah, this is a thought experiment. We're not trying to make this overly complicated. What would you like to do to the numbers? What do we want for X and what do we want for Y? 2 and 2. Thanks, Dat. Okay, so Dat has chosen 2 and 2. Okay. I love that increase B. Yeah, what numbers, Ivan? Oh, Dat understood what I was saying. Maybe my question was at fault. So, okay. So what Dat has now done, Dat is now previously, to determine A, to figure out A's order, we compared experiments 1 and 2. Now we want to find the order with respect to B. Now, isn't that interesting? Kayun did something different. She changed the number of A back to 1. Very interesting. I'm going to stick with Dat's Kayun just on this, but we can do yours as well. So we now want to find B's order. Yeah? What's its impact on the rate? Yeah? So this time, in order for us to work out B, thanks to Dat's choice, we now need to compare 2 and 3. Because he kept A constant. A is kept the same. And he now doubled B. And here's what happens to the rate. The rate has doubled. Would anyone like to guess the order with respect to B, please? Would anyone like to guess on the chat? So, as a result of our thought experiment, I love thought experiments. Einstein was a genius. So, we doubled conc of B times 2, rate times 2. What order am I going to give to B in symbol? First order, thank you, Dat. And we give it an order of 1. So this is now first order with respect. Respect, man! Oh, I don't know why I went Jamaican. I have no idea what just happened. Damn it. Sorry about that. First order with respect to B. Yeah? And what that tells me, yeah, this is first order. Yeah, just a 1. First order Yeah, if I were, so what does this actually mean? What this means is dot, 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 if we dot, 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 if we took the concentration of B and timesed it by 4, what would happen to the rate? Question mark. Yeah, what would happen to the rate if I multiplied B by 4? So can the order of a reactant be determined by experiment data only? Kayun, well done. Kayun, you cannot guess the order of a reactant. You can only work it out through experimental processes. That is absolutely correct. Well done for picking that up. Well done. So I'll just quickly write that down. Nota bene. An order of reactant can only, underline only, can only be found experimentally. Oh, experimentally. There we go. It's the only way it can be. Thank you, Dat. If you rate stays the same. No, Ivan. Oh. Did the rate stay the same up here, Ivan? A doubled B. What's going to happen to the order? What's happened to the rate? Thank you, Dat. Someone's paying attention. Rate times by 4. Yeah? It's first order. It's directly proportional. A is 0. You times A by 4, no change. But B is first order. If I multiply the concentration of B, I will multiply the rate by the same factor. Yeah? So what does the graph look like? So here's the concentration of B, and here's the rate. Yeah, moles per dm cubed per second. B, of course, is moles per dm cubed. Right, what's this graph going to look like, folks? Won't B be limited by A? To a certain, right, so Ivan, you guys are very bright. Yeah, it's a directly proportional graph. If you multiply B by 2, the rate will also increase by 2. Yeah, it's directly proportional. But Ivan, you're absolutely right. There will be limiting factors. And if you kept going, eventually it would level out. But we never talk about this section. Yeah, this is the section you need for A-level. This is the question you're going to get on the graphs. Yeah, just that section. This bit is just going a little bit beyond. But it would become... You can make another nota bene. Nota bene. All reactants will become zero order once in blank. What's the last word, folks? How do I finish off that nota bene, by the way, is super important. That comes up a lot in Excel, and teachers always forget to teach it. So all reactants will become zero order once in, what's the last word, folks? So Ivan, won't B be limited? B could be limited by A, yes. And in fact, this little red bit here is going to explain that. Yeah, it would. If you haven't got enough A, then... But that doesn't change what we observe in the rates, Ivan. It doesn't affect that. Yeah. We still need to have a certain amount of A for B to be able to do what it's doing, but we know that if you add more A, it doesn't change the rate. Yeah, we just need to have a minimum amount of it for us to be able to get to the rate that we predetermine, or that we want. Thank you, Ria, you star. Yeah, I'm actually going to do that one in green, nice and fat, excess. Well done, Ria. All reagents become zero order if they're in excess. If you just keep adding it, and this here is the excess part of the graph. Yeah, it's got, if there's so much, you can't just keep adding more and more and more and more and more and expect the rate to increase. It will eventually level out. But this graph here, that there says first order. Yeah, first order. Yeah, okay. I'm very aware that I've only got 10 minutes left of my lesson. I need to do one more. Let's do one more thought experiment. Right. So, in this thought experiment number 2. So we're going to do the reaction of A plus B plus C goes to, let's just do A, B, C, D. That makes no difference. Yeah, we're going to do this experiment. We got 3 reagents. We're going to assess their effects of concentration change on the rate. Yeah, so we're going to start off with EXP1, experiment number 1, and we're going to have 1, 1, and 1, and we're going to be measuring over here. It doesn't matter what we're making. Nothing matters in rates in terms of products. It's just the reagents because it's unidirectional, and we're going to stick with 10. Let's keep it easy. Right, so EXP1. So EXP2, we're going to double A and keep these two the same. And look what happens to the rate. Guys, what is the order with respect to A, please? As a result of these two, what is my order with respect to A? Go. Next, EXP3. Yeah, we're going to go 1. I've gone back to yours, Kayan. Yeah. So I've done that one now. So I've doubled B. And look what's happened to the rate. Right. Now, thanks to these two, we can now work out B's order. Yeah. Let's do one more experiment. EXP4. 1, 1, and 2. And what happens to the rate? It goes up to 40. So, as a result of these two experiments, I can now determine C. What has C done? So, well done for, I have got, Ivan and Kayan have both got A, well done. A is 0 order, well done. A is 0 order, well done. Great job. It had no effect on the rate. Yep. B, what's B's order? Come on, folks. What's B's order? B's order is first. It's first order. Thank you very much, Ivan. Ivan, well done. B is first. Right, no, Kayan, C is second. C is second, but Kayan, did you jump the gun there? Are you saying that B's... Because look at what we did. For experiments, I'll stick with the green. So let's, in fact, do all these as color-coded. So with A, we said we doubled A times by 2, and the rate did nothing. No change. So A becomes first as a result of that. Sorry, becomes 0. 0. Sorry. 0. Look at B. I'm going to change my color to match. Yeah. So B, what we now did was we doubled B times by 2. Yeah. And we kept, sorry, I've just suddenly made a mistake. Sorry, I've written that in the wrong place. Sorry, apologies. Sorry, it was a habit from my previous one. No change on the rate. Yeah, no change on rate. Now I've doubled B, yeah, and I kept all the others constant, yeah. C is second. No, I meant C. Well done. So I doubled B. Look what happened to the rate. The rate doubled. We're okay with this? Yeah, went up by times 2. These two match. Yeah, these two here match. It's first order. That makes sense. Yeah, next. What now is C? Change my color to match. Purple. I need more colors. Oh my goodness, purple. Purple. So here, I doubled C, yeah, but the rate went up by 4. Now, how does that give me second order? Now, hopefully, guys, I'm hoping that you guys are going to go, I understand now why you write it in the corner, because it's a power. Yeah, these orders are powers. C, we times the concentration of C by 2, but its order is second. What that means is whatever we have got in here is going to become squared. The rate increases by 2 squared. Yeah, the rate will increase. Yeah, will increase by 2 squared because it's second order, which is therefore 4. Yeah, increase by 4. So, okay, I'm going to do one more thought experiment. So now we have determined everybody's order. Yeah, everybody's order is found. We know that A is first in red. A is first. No, A is 0, sorry. B is first. I'm getting my numbers jumbled up. And then C is second. Cool. So we've worked out their orders from the data. Okay, so here's just one more thought experiment before the lesson ends. In fact, I think it already has. Uh-oh. No, I've got 5 more minutes. It's all right. EXP 5. I'm going to go 1, 1, 3. I have multiplied C by 3. Can everybody now tell me what the rate is going to become as a result of that, please? Last question, I promise, folks. Yeah, what's going to happen to the rate? Somebody give me the number. Who's going to be first on the chat? Who's going to win? Everybody else has been kept constant. We have multiplied C by 3. I'm doing a different color. Times by 3. So what's the rate going to be? Dat, well done. Ivan, nope. Ivan, C is second order. 80? No. So if we have taken C, this is where this is why I have to make sure I go through these. Yeah. C is second order. Yeah. I have now multiplied C by 3. So what is 3 to the power of 2? Is 9. The rate is going to increase by a factor of 9. So it's going to end at 90. Well done for those people. Well done, Emma. Well done, Dat. Good job. Right, guys, that brings me to the end of my lesson today. Hello, I'm back. Guys, I hope that all makes sense. I will post questions on the classroom. Can I just point out, we're not done yet. Next lesson, I'm going to go through what's called stepping. Yeah. And I don't need to worry about this. I will set you some questions on the classroom for homework for our next lesson, which is when? Our next lesson is tomorrow. I will set them now. I've already given them to the other class. And you can have a go at doing the questions. They get trickier, I promise you. This will get harder, and we need to spend a bit of time doing these questions because it takes a bit of a while just to get your head around it. But I promise the penny will drop and it'll be like, oh, okay, I get it. Yeah, I promise it will clear up. Guys, go and have a lovely rest of your day. I'll see you guys all very soon. See you later, guys.